Hello Algebra 2 students. This video will be reviewing Regents questions on Unit 10 Probability. Each section will be a different standard within probability that the Regents could test you on. First is theoretical probability. The probability that Gary and Jane have a child with blue eyes is 0.25, and the probability that they have a child with blonde hair is 0.5. The probability that they have a child with both blue eyes and blonde hair is 0.125. Given this information, the events blue eyes and blonde hair are dependent, independent, or mutually exclusive. First, let's just check our independence test. Your independence test states that if your events are independent, then the intersection of the two events will have the same probability as multiplying the two events by each other. This would only work if they are independent. So let's check that out. There's the event of blue eyes. There's the event of blonde hair. And having both, so the intersection, would be 0.125. I'm going to put this in my calculator, and I see that they are the same. So since they are equal, it passes the independence test. That means that those two events are independent. Okay, a suburban high school has a population of 1,376 students. The number of students who participate in sports is 649. The number of students who participate in music is 433. If the probability that a student participates in either sports or music is 974 out of 1,376, what is the probability that a student participates in both sports and music? So if they're participating in both sports and music, we're going to want to find the intersection. So P of A intersect B equals the probability of one event plus the probability of the other. But remember, if you are adding these two events, so you know what, actually I want to manipulate this formula because it's easier to explain the other way. So let's say the probability of A union B, so we're talking about what's in both sets, how many terms are in both sets. So you take the probability of one event, you're going to add it with the probability of another event. But let's say that those two events intersect at any point. You just counted those intersections twice. So you could subtract the intersection. Right? That's where that formula comes from. But what I was doing in the beginning, which we're going to manipulate it to, is technically you could just add this over. And then you could subtract the union over. So that cancels out. That cancels out. So it's interchangeable where you put the intersection or the union in the case of this formula. So you just have to remember that you're subtracting something, either the union or the intersection, whatever you don't put that it equals. Or you could leave it to the last step when you plug in the numbers and then just solve. It's just easier when you're just plugging in and putting everything in a calculator. So the number of students who participate in music is 433, and that's out of 1,376 students. Probability of students who participate in sports, 649 out of 1,376. And then for those that participate in either sports or music, so they counted all of the students up in both sets, that's your union, 974 out of 1,376. And then we want to find what this intersection will be. If you want, you could just add up the numerators because you have a common denominator. So 433 plus 649 minus 974. And you get 108 out of 1,376. So that's the probability of people that participate in both sports and music, the intersection. Something else that you could have done, you could have drawn a Venn diagram. So I'll just show that quick because some people might prefer that. You draw your universe or the sample space. There's 1,376 in the whole school, so it should all add up to 1,376. You have two sets of people that do intersect, so they're connected. Number of students who prefer sports, number of students who prefer music, and this would be both. The number of students that prefer sports is 649. You would still have to use the formula though. Okay? If the probability that a student participates in either sports or music is 974, so we could subtract 1,376 from by 974, and you would get 402 students that aren't in either sports or music. We already said that the intersection, right? Again, you'd have to use that formula anyway. You would get 108. And then for the people that are in sports, you would do 649 minus 108, which is 541. You would do 433 minus 108, because that's the intersection, 325. And then that's the whole set. That's everybody that's in the school. Personally, I think it's easier to use the formula, but it might be easier to visualize what's going on when you have the Venn diagram. Okay. You're given P of A equals 1/3 and P of B equals 5/12, where A and B are independent events. Determine P of A intersect B. So, the key piece of information here is they're independent. So you know that P of A intersect B will equal P of A times P of B. So you're just going to plug it in. 1/3 times 5/12. This would only work if they're independent. You end up getting 5 out of 36. Okay. In contract negotiations between a local government agency and its workers, it's estimated that a 50% chance that an agreement will be reached on salaries, 70% chance agreement will be reached on insurance benefits. So salaries is 50%. Insurance benefits is 0.70. There is a 20% chance that no agreement will be reached on either issue. Either issue. Either is essentially saying or, right? Or if we're saying something that's in this set and everything that's in this set, right, then that's your union. So it's S union I, but it's saying no agreement will be reached. So we're actually going to be finding the complement of that set. It's everything that's not in that set. It's everything that's out here. So the complement is 0.20. Find the probability that an agreement will be reached on both issues. So both means that the agreement will be reached on this issue and the agreement will be reached on this issue, meaning the intersection has to fit both criteria. So we're trying to find the intersection. Based on this answer, determine whether the agreement on salaries and agreement on insurance are independent events. Okay, so there's two parts to this. So first, we're going to have to use that formula that we just used. P of A, we're trying to find the intersection, so A intersect B equals P of A plus P of B minus P of A union B. Again, I change it depending on what we're solving for. We're solving for the intersection, so I made the equation equal to the intersection, and I subtracted the union. You could make it equal to the union if you're solving for the union, and subtract the intersection. So, let's plug in 0.50 plus 0.70 minus, is it going to be 0.20? Is this the complement of S union I? No, it's the union. So what's everything in the set other than the 20%? We're going to have to do, in this case we'd be doing 1, but I think it's easier for students to see 100% minus 20, which is 80%, right? So P of S union I would be 80%. All we have to do now, put that in our calculator. 0.5 plus 0.7 minus 0.8. You get 0.4. So there's a 40% chance that there will be an agreement on both issues. Okay. If you want, let's make it more specific to the question. Okay. Now it says, based on this answer, determine whether the agreement on salaries and agreement on insurance are independent events. You could do two things. You could do your independence test. So P of A intersect B has to equal P of A times P of B. P of A intersect B, we already said was 0.4, should equal the two separate probabilities multiplied by each other. So 0.50 times 0.70 is 0.35. You could see right there that these are not independent. They're dependent on each other. Or the method that I prefer, we could use the conditional probability. So let's say P of A is given B. That's the same as saying P of the intersection of A intersect B over P of the given condition. So P of B. So you're changing the sample that you're looking at when you do a conditional probability. This should all equal P of A if they're independent events, because it shouldn't depend on changing the sample. The reason I prefer this method is that I think it makes more sense as to why you're doing it all. This is just a formula that we derived. So, the intersection of salary and insurance were 0.4. The probability of, let's say we should make it a little bit more specific to the question, because technically you could go both ways. P of S given I. So the intersection of S and I was 0.4. Probability of I was 0.70. Probability of the event, which is S in this case, is 0.5. So 0.4 divided by 0.70 is 0.5714285714. You can see clearly that this is not independent. They're not the same number. So you could say the two events are not independent. On the region, I would say the agreement on salary, the events of the agreements on salaries and the agreement on insurance are not independent, or the agreement on salaries and the agreement on insurance are not independent events. Okay, we're given a Venn diagram. If students from high school is selected at random, what is the probability that the student is a sophomore? So what is the probability that a student is a sophomore given, this line means given, that the student is enrolled in Algebra 2? So this is conditional probability. The minute there's a given condition, that's conditional probability. So you're going to do the intersection of sophomore and Algebra 2 over the probability of the given condition, which is Algebra 2. Right? This is the event, this is the given condition. So, and by the way, I'm using P for probability, but you could interchange that with N for number. In this case, we're going to be using the number. The reason that works is because you'd be doing a fraction divided by a fraction, and your denominator would always be the entire the entire sample space. So when you're doing keep change flip, the denominator cancels out. So that's why it works both ways. So S intersect Algebra 2, the intersection is 85. And then out of the number of students taking Algebra 2. So, number of students taking Algebra 2, do not forget that intersection. It's going to be 210 plus 85. So that's 85 out of 295. It's answer choice number 2. That's conditional probability. In a group of 40 people, 20 have brown hair, 22 have blue eyes, and 15 have both. How many people have neither brown hair nor blue eyes? There's two things you could do. You could make a Venn diagram, or you could use the formula. Neither is going to be the complement of your union. So, first let's find the union. So, blue eyes and brown hair. And again, I'm using P here in my formula, but you could put N to interchange it with number. Technically, we're using the N because this equation is giving us the N. So, brown hair was 20, blue eyes 22. 15 have both, so the intersection would be 15. 22 plus 20 minus 15 would be 27. So, there's 27 people that have both blue eyes. I mean, I should say blue eyes or blonde hair, brown hair. I'll use N. So, we want to know everyone in the set that doesn't have either. So we're going to do 40 Let me just write down the complement of that set. (40 minus 27). That would be 13. Okay. Conditional probability. Which situation best describes conditional probability? Finding the probability of an event occurring 2 or more times. Finding the probability of an event occurring only once. Finding the probability of 2 events occurring at the same time. Finding the probability of an event occurring given another event has already occurred. Remember, conditional probability is when you have a given condition. Okay, we're given another conditional probability question. The probability that a resident of a housing community opposes spending money for community improvement on plumbing issues is 0. Opposes spending money for community improvement on plumbing issues is 0.8. The probability that a resident favors spending money on improving sidewalks given that they oppose plumbing is 0.85. Determine the probability that a randomly selected resident opposes spending money on plumbing issues and favors spending money on walkways. Okay. So, we have what they gave us was, they probably should have, defined what those variables mean. I'm assuming F is favors and D. I believe we had an issue with this question in class when we went over it. And when looking up the problem, the reason I actually gave a different one. It was just an issue with the form. Let me see. That we're given. Let's see. Okay. Probability that a resident of a housing community opposes spending money for the community. Determine the probability that favors spending money on walkways. Okay. So, we could just actually ignore this part of the question. It's just what it wrote. What it says here. Determine the probability that a randomly selected resident opposes spending money on plumbing issues and favors spending money on walkways. So, we're given the probability of, let's say, P is 0.8. The probability of walkway given P equals 0.85, which we know that this follows the formula of P W intersect P over the probability of the event. So we want to find that they have and favor spending money on walkways. So we want to find that intersection, right? So we could plug that into the formula. 0.85 equals the probability of the intersection over the probability of P was 0.8. Just multiply by 0.8 on both sides. Put that in your calculator. But yeah, when I just looked it up, the Regent didn't have this part. So if that part's confusing you, technically you're supposed to define you're supposed to define. That's so weird. What I'm thinking happened is maybe this got tagged on from another question, because this is actually the right answer, what we got, and it's none of these answer choices. Okay? Sorry that happened. Now we understand why it was so confusing in class, this question. So this was the question on the Regent, and all you had to do, the given probability is of this formula, alright? And it equals 0.85. The probability of opposing plumbing was 0.8. You plug in those two numbers into that given formula, like the conditional probability formula, and then you just have to solve. It's just, unfortunately, I think the document that I screenshotted the question for, I think that another question was attached to it. Okay. Conditional probability. What is the probability that a person texts over 50 messages per month given that the person is between ages 23 to 60? So you're going to do the intersection of greater than 50 and 23 to 60 over the probability of the given condition. So, probability of the intersection of greater than 50 text messages and 23 to 60 age range is 157. And then the probability, or the number, of the age group 23 to 60 is all of this. Unfortunately, they didn't give us a total, so we're going to have to add them up. So 25 plus 47 plus 157 is 229. That is number one. Okay, the results of polls of students. For this group of students, these data suggest that gender and preferred music styles are independent of each other. So, let's choose a preferred music style. Again, you could use your independent test, but I like to do conditional probability. So, I'm going to do the probability of let's choose rap. So 25. So the probability of preferring rap given that they're female, probability of preferring rap given that they're male, and the probability of just rap in general, of preferring rap. So we would do the intersection of female and rap, which is 25, over the number of females, then you're going to do the intersection of males that prefer rap over the number of males. And then for rap, you would do the number of people in rap, so 25 plus 40, over the total number of people, so 200 students. So if they're independent, all of these numbers should be the same. Not even close. So it's clearly dependent on gender. Your preferred music style. So for this group of students, gender and preferred gender and preferred musical preferred music styles are not independent of each other, since after determining the probability of students that prefer rap, given that they are female, given that they are male, and given the entire sample space, these probabilities were all different depending on the gender. Okay. Conditional probability. Determine the probability of P given K. So, how many students were in both physics and key club? 1.9% are in both. Then what's the probability that are in key club? 8.6%. Oh, it's percent. You end up getting 0.2209302326 to the nearest tenth of a percent. So this may turn into a percent, and it will be about 22.1%. Okay. Okay. So then it says the principal would like a basic interpretation of these results. Write a statement relating your calculations based. Write a statement relating your calculated probabilities to student enrollment in the given situation. So what we calculated, the probability of selecting a student in AP Physics given that they are in Key Club is 22.1%. We should use the word enrolled just because it says relating it to student enrollment. Enrolled in Key Club is 22.1%. Okay, and then lastly, a study was designed to test the effectiveness of a new drug. Half of the volunteers received the drug, the other received the sugar pill. So, received drug, 0.5, received sugar pill, 0.5. The probability of a volunteer receiving the drug and getting well was 40%. What is the probability? Okay, probability of a volunteer receiving the drug and getting well, so that's the intersection because it meets both criteria, is 0.4. What is the probability of the volunteer getting well given that the volunteer received the drug? So probability of a volunteer getting well given that the volunteer received the drug. So we're going to have to do the probability of the intersection of getting well and receiving the drug over the probability of receiving the drug. So we already were given the intersection, 0.4. Probability of receiving the drug is 50%. 0.4 divided by 0.5. 0.8. So it's about 80% chance of them getting better. Okay, hopefully that helped. Thank you.